Z to represent a complex number generally, like Z might be A plus BI, and then we use Z with a line above it, or sometimes you might see an asterisk in the book. We SACE and my test, and that we use this notation, okay? Means the conjugate, so that's going to be A take BI. Alright, so it's got the line above it, it means the conjugate. So what we're going to prove here is that the conjugate of the conjugate equals Z. Okay, so the way we start off with proofs is we might start with the left-hand side and the right-hand side, and we're going to manipulate it and show that it's equal to the other side. So the left-hand side is, I'm just going to make the statement, and we're going to let Z equal A plus BI. So it's going to be A plus BI, the conjugate of A plus BI, and then conjugate. Okay, so this would be A take BI, and the conjugate of that, which would be A plus BI, which is the right-hand side. Okay, the next example, we've got the conjugate of Z1 plus the conjugate of Z2 equals the conjugate of Z1 plus Z2. Okay, so let's define Z1 as A plus BI and Z2 as C plus DI. So we're proving this for all complex numbers. So then the left-hand side is going to be the conjugate of A plus BI plus C plus DI. Alright, so that is Z1 plus Z2. Now what we're going to do here is collect the real components and the imaginary components. We're going to have A plus C in brackets, and then plus I times B plus D. Okay, so A plus C is going to be a number, B plus D is going to be a number, and now we're ready to form the conjugate of it. If we conjugate it, it's going to be A plus C take I times B plus D. Okay. And like when you're at this step, what you could do is we could go to the right-hand side and manipulate the right-hand side to get to here, but we can actually continue on and get this all the way to the right-hand side. So I'm just going to do that. So we've got A plus C take BI take DI, just by expanding the bracket. So that's going to be A take BI plus C take DI, which is the conjugate of Z1 plus the conjugate of Z2, equal to the right-hand side. Alright, so they'll get a bit more complex than that, but the principle remains the same. We start with A plus BI, C plus DI, and doing those kinds of proofs. Cool, let's do it.